Hello everyone, welcome to you all to another video lecture of Calculus 1. In this lecture, I'm going to explain how the functions behave when x goes to infinity and negative infinity. Uh, on the other words, how the function behaves when x becomes large positively and negatively. So this is called limits at infinity. Limits at infinity. So basically, what we're going to see is for any function fx, what happens when x goes to infinity. When x goes to infinity, if fx goes to L, uh, it could go to L, or when limit goes to negative infinity, fx can go to L. L could be any number. So in that case, this y equals L line, so y equals L line, this is fx, or fx equal L, y equals L, would become a horizontal asymptote. This is called horizontal asymptote. So if you're asked to find horizontal asymptote of a function f of x, what would you do is you would find the limit x goes to infinity, f of x, then you'll get some number that's your horizontal asymptote. Uh, for example, I get a special function that's called exponential function. Exponential function, uh, if I look at exponential function, the limit of exponential function as x goes to infinity, limit of exponential function dx as x goes to infinity, this goes to infinity, and limit x goes to negative infinity, e to the power x or exponential x goes to 0. So uh, if you draw f of x e to the power negative x, it looks like that. So this, as x become larger and larger positively, it goes to higher and higher. That's positive infinity, and then here it's x become larger and larger negatively, which goes to uh, 0. And for trigonometric functions like like sine x, uh, f of x equals sine x, this function oscillates when x goes to either positive and negative infinity, so the limit does not exist. Okay, the limit does not exist. And we're gonna talk about a category of functions called rational functions in this lesson. Before that, let's look at some basic elements that builds up to rational functions. So I'm going to take out a function f of x equal x to the power n, and this n could be any positive number, any positive number. Uh, so if it is any positive number, limit x goes to positive infinity, x to the power n goes to infinity, right? This is for any positive number. and limit x goes to infinity, x to the power negative n, right? That means that is equal to limit x goes to infinity, x to the power 1 over 1 over x to the power n goes to 0, right? For any positive integer, for any positive number, okay? So, but if now the things changes when n is a positive integer. When n is a positive integer, when x goes to negative infinity, things changes, right? When x goes to negative, because we can we for any positive number n, when x goes to positive infinity, this holds. But when x goes to negative infinity, it depends on whether the number is positive integer or not. So if it is a positive integer, when limit uh, x goes to negative infinity, x to the power n, right? X goes to negative infinity, x to the power n. Uh, now n is a positive integer. If now it goes to positive infinity when if n is even, and it goes to negative infinity if n is odd. Okay, it goes to negative infinity if n goes to n is odd. So I can show you this. If you consider f of x equal x cubed, now it's a uh, odd n value, odd positive integer. When x goes to positive infinity, right? Positive n right there, it's 3, right? You can see that according to this, when n goes to uh, positive, when n is a positive number, this is a positive number and it's also a positive integer. X goes to positive infinity. It doesn't matter if it is a positive number, it goes to infinity. So that goes to infinity. Okay. Now, if n is odd positive number, when it goes to negative infinity, x goes to negative infinity, this goes to negative infinity. So this is x, right? And the next thing is if you consider the limit x goes to negative infinity, x to the power negative n, right? It doesn't matter it is a positive, even or odd, it doesn't matter, even or odd, that limit x goes to negative n, sorry, negative infinity, x to the power n goes to 0. So for all the n numbers which are greater than 0, all the positive numbers, this holds, right? So once again, if I summarize this, right? If I summarize this, for all n greater than 0, uh, limit x goes to infinity, x to the power n goes to infinity. and limit x goes to infinity, x to the power negative n goes to 0. For positive integers n, or positive n is a positive integer, limit x goes to negative infinity, x to the power n equals positive infinity if n is even, goes to negative infinity if n is odd. And limit x goes to negative infinity, x to the power negative n equals limit x goes to that goes to 0. Okay. And what if you have a rational number if x goes to negative infinity, which is a somewhat, which is another case. So let's see, you have p and q uh, greater than 0 and integers. P and q are integers and greater than 0. So q is odd. When q is odd, uh, limit x goes to negative infinity, x to the power p over q goes to infinity. Uh, if p even, right? And limit x goes to negative infinity, x p over q goes to negative infinity if p is odd. Okay, if p is odd. Now in this case, q is odd. When q is odd, p is even, it goes to positive infinity. When q is odd and p is also odd, right? That's going to be an odd number. P is odd and q is also odd, right? Then it goes to negative infinity when x goes to negative infinity. What if q is even? When q is even, right? X to the power p and q is not defined. Defined for x values less than 0. Why? Let's see, you have q even, right? Q even value is, let's talk about something like this, 1/2. Okay, 2 is an even number. And if you have a negative value, 1/2 is actually square root of x. Now x cannot assume negative values. Why? As soon as it becomes negative value, this become a complex number. So those are not included in real numbers. So that means when x is less than 0, this becomes complex number that is not included in real numbers. Okay, so this case is not defined. So what you have to keep in mind is when q is odd and P is even, this goes to positive infinity. When Q is odd and P is odd, goes to negative infinity. Okay, you don't have to actually remember these things when we work the problems. You get used to this, and it's going to be really easy to use them. Let's work on an example. Example one. So we have calculate limit, pick another, limit x goes to infinity, 20x squared minus 3x divided by 3x to the power 5 minus 4x squared plus 5. Now when x goes to infinity, both numerator, now this goes to infinity and this goes to infinity, right? So that is actually not it's an indeterminate case, as we talked in the previous class, right? So what can we do? What are we doing here is we get the highest power of x term, highest power of the x term in the denominator, highest power of the x in the denominator, and divide all the terms by the highest power of the x term in the denominator. So what I mean by is the highest power of x in the denominator is x to the power 5. So we divide both numerator and denominator by x to the power 5. So we divide limit x to the power, x goes to infinity, 20x squared divided by x to the power 5 minus 3x divided by x to the power 5 divided by 3x to the power 5 divided by x to the power 5 minus 4x squared divided by x to the power 5 plus 5 divided by x to the power 5. So we can simplify it a little bit. Limit x goes to infinity. This is 20 divided by x to the power 3 minus 3x divided by x to the power 4. And then we have 3, just 3 because x to the power 5 cancelled x to the power 5 divided by 4 x to the power 3 plus 5 x to the power 5. Now, by applying basic limit laws, we can apply the quotient law and summation law, right? We can take limit x goes to infinity, 20 divided by x to the power 3 minus limit goes to x infinity, 3 divided by x to the power 4 divided by limit goes to infinity, 3 minus limit goes to infinity, 4 over x cubed plus limit x goes to infinity, 5 over x to the power 5, right? Now, 20 is a constant, so you can pull that out. And then 1 over x to the power 3, when x goes to infinity, right? Based on our uh, laws, what we learned previously, this goes to 0, right? This is right here. This one goes to this. This is where it comes from, right? It goes to 0. Negative n is 1 over x to the power n. So you have 1 over x to the power n here, 1 over x to the power n here, 1 over x to the power n here, 1 over x to the power n here. So everything goes to 0 except this one. This is 3, right? So what we do is this is 0 minus 0 and 3 minus 0 plus 0, right? So this 0 over 3, that's 0. So the limit answer is 0. So this is the same thing that we need to do. Uh, let's do some examples, some more examples. And I'm going to pick number 8 from the book. Question number 8. Limit x goes to infinity, 3x squared plus 20x divided by 4x squared plus 9. Uh, what is our method? We're going to divide everything by the highest power of x in the denominator. So we do limit, what is the highest power of x denominator? X squared, right? So we're going to divide everything by x squared, both numerator and denominator. X squared, 3x squared divided by x squared plus 20x divided by x squared, and then 4x squared divided by x squared plus 9 divided by x squared. Right? Very simple. Okay. Then you can cancel this out. You get limit x to the power, x goes to infinity. This is 3 plus 20 divided by x divided by this is 4 plus 9 divided by x squared, right? So when x goes to infinity, limit of 3 is 3 plus this is 1 over x, so that goes to 0. This goes to 0. And next term, this one is 4. So we have 4. And the last term in the denominator goes to 0. So it's 3 over 4. Make sense? Okay. So that's how you uh, do those problems. Let's take another example. What is our next example? Our next example would be number 14. Number 14, number 14 of the textbook. This is the problem. Limit x goes to infinity, 5x minus 9 divided by 4x cubed plus 2x plus 7 equals, you have to divide all the terms by x cubed. So limit x goes to infinity, 5x divided by x cubed minus 9 divided by x cubed divided by, and the denominator 4x cubed divided by x cubed plus 2x divided by x cubed plus 7 divided by x cubed. So we have limit x goes to infinity, 5 divided by x squared minus 9 x cubed divided by 4 plus, here is 2x squared uh, plus 7x cubed, right? Um, so if you have any x to the power negative n, so here in this term, uh, sorry, this term goes to 0, this term goes to 0, this is 4, 0, and 0, right? So let's write that. So this is 0 minus 0, 4 plus 0 plus 0, so it's go to 0, right? The limit is 0. Our next example is 19. So we're going to talk about example 19. Okay, which is interesting. So 19, limit x goes to infinity, uh, x goes to infinity, 36 square root of 36 squared plus 7 divided by 9x plus 4, right? So we can apply some of the terms here. Uh, so what we're going to do is we're going to uh, divide this by x, right? Because that's the highest order of x in the denominator. We're going to divide this everything by x. Okay, so let's divide this by x. So we have, sorry, I had to write this, limit x goes to infinity, uh, limit f goes to x goes to infinity. Uh, so what we have to find is the horizontal asymptote. So uh, we need to find what the limit, what happens when limit goes to infinity, positive infinity and negative infinity. Okay, so because we need to find vertical asymptotes, we need to find vertical asymptotes of this function f of x. Okay, this function f of x. Uh, so we divide it by x. We divide this by x, so it's 36 x squared plus 7 divided by x, and then the denominator 9 divided by x plus 4 divided by x. Okay, so now this is x. If you want to take this into the square root sign, you need to uh, make this is x squared, right? So what I can do is limit x goes to infinity. This would become 36 x squared plus 7 divided by x squared. Now this x is in the radical or the square root sign. 9 plus 4 divided by x. And then we can make things simplify inside the square root sign. So we have this 36 plus 7 divided by x squared in the square root sign, and then at the part denominator you have 9 plus 4 over x. Now we can use the power rule or square root rule, uh, and then we can move this limit into the square root. So it's going to be square root of limit x goes to infinity 36 plus limit x goes to infinity 7 over x squared divided by limit x goes to infinity. We have used the quotient rule as well here. Limit x goes to infinity 4 over x. This is in the square root 36, and the second term inside the square root 7 over x squared. So this term goes to 0 when x goes to infinity. So you can put 0. and the denominator you have 9 plus 0. So square root of 36 is 6, and 6 over 9, that is 2 over 3. 2 over 3. Now that is the horizontal asymptote when x goes to, this is the horizontal asymptote when x goes to infinity. And what happens when x goes to negative infinity? So when x goes to negative infinity, now we have the same function. We get limit x goes to negative infinity. You have same function 36x plus 7 uh, divide 36x squared plus 7 divided by 9x plus 4, right? And it's the same thing. You divided by x both side, both numerator and denominator, and you're gonna end it up in the same thing, but limit x goes to negative infinity, right? You're gonna end it up in uh, 36 plus 7 x squared divided by 9 plus 4 over x, right? Um, when this goes to uh, negative infinity, uh, when this goes to negative infinity, what would happen is uh, you can multiply this by a negative value because now x is negative, right? So you should be multiplying uh, the rather than dividing by x, you'll be dividing it by uh, negative x, right? You're going to be dividing it by negative x. Uh, so in this case, you have uh, a negative sign, right? Negative sign. So you have limit x goes to negative infinity. It's going to be, this portion is 0. This portion is 0. So we have negative 36 by 9. So it's uh, negative 6 over 9. So it's negative 2 over 3. So y equals negative 2 over 3 is a horizontal asymptote. Okay. Now the next one is 21. 21. Okay. You are given number 21. You are given f of t equals e to the power t divided by 1 plus e to the power negative t. This problem 21. When now we need to find what are the horizontal asymptotes. So first consider when limit of f of t t goes to infinity, limit t goes to infinity, e to the power t divided by 1 plus e to the power negative t. When it goes to e to the power t, this goes to infinity. So the numerator, so it goes to infinity, right? Everything is goes to infinity. This goes to zero, but infinity over one is goes to infinity, right? Because this part goes to infinity and this part goes to zero, right? So that goes to infinity. I'll write that step. I'll write that step. So we have infinity on the numerator and then 1 plus 0. So that is infinity. And then negative infinity, t goes to negative infinity, f of t equals limit t goes to negative infinity, e of t divided by 1 plus e of negative t. Uh, so when it goes to negative infinity, this becomes smaller and smaller, so it's going to be 0. And when t becomes larger and larger, even though this is large number, this is 0, and then everything goes to 0. Okay, so this has only one horizontal asymptote, y equals 0, and this not a give horizontal asymptote because it goes to infinity. And the next question is 28. Evaluate the limit. So 28, evaluate the limit. We have what? Limit, sorry, limit x goes to infinity, square root of x to the power 3 plus 20x divided by 10x plus minus 2. Now, the highest power of x in the denominator is x, so I can take that value and divide everything by that. So I will divide that, right? Um, x cubed plus 20x divided by x by 10x over x minus 2 over x, and limit x goes to infinity. This would be x squared plus 20 divided by uh, x cubed over x squared and 20x over x squared and divided by 10 minus 2. Because when you take this into the square root sign, it's going to be x squared, right? That's why like that. So we have limit uh, limit x goes to infinity. Within the square root sign, you have x plus 20 over x divided by 10 minus 2. So this goes to infinity because x goes to infinity. This goes to 0. So when you're doing it, this x goes to infinity. So then everything goes to infinity. Okay. Next one is 29. So we'll do example 29. Limit x goes to uh, negative infinity, 8 times x squared plus 7 times x to the power 1/3, right? Divide x to the power 4 plus 6. Question number 29. So what we are going to do is we're going to do divide by the highest power in the denominator, which is x to the power 4. Um, so, but it is in the radical. So if you in the radical in the square root is inside the square root, x to the power 4 is x to the power 2, right? When you take it out. So basically what we are doing is this. We're gonna 8x squared, right? But the thing is that since x goes to negative infinity for x less than 0, uh, x to the power minus 1 is equal negative x to the power minus 1, right? And that is equal to negative times x to the power minus 2, okay? Negative times square root of x to the power minus 2. So we're gonna uh, divide this uh, in this case, actually in this case, for x less than 0, uh, we have in this case actually we have x to the power squared, so x to the power negative 2 is equal to uh, positive because it's an even number. I was thinking it is negative power 1, so you have x to the power negative 2 is equal to x to the power negative 2, which is equal to square root of x to the power negative 4, right? Square root of x to the power negative 4. Uh, so what we're doing here is uh, divide this by x to the power 4 or multiply this by x to the power negative 4. So we have 16 x to the power 4 divided by x to the power 4 plus 6 divided by x to the power 4, and then on top this is divided by x to the power 2, so that's equal to that, right? And then plus 7 x to the power 1/3 divided by x to the power 2, right? And then we're gonna end it up in 8 plus this is 1/3, and you will be having x to the power 5/3, right? By square root of 16 plus x to the power 6 divided by x to the power 4. So this is limit goes to infinity, negative infinity. Okay, and then you have when negative infinity, uh, these two numbers are odd, so that goes to this is negative number, so it goes to 0. So this number goes to 0. So it's going to be 8 plus 0 divided by 16 plus 0. So it's 8 over 4, which is 2. And that is 29. If I work on 32, um, limit t goes to infinity, t to the power 4/3 minus 9 t to the power 1/3 by 8 t to the power 4 plus 2. Everything is 1/3. And the highest power in the denominator is, you can take it as t to the power 4. You can divide everything by t to the power 4, t to the power 4 uh, in the radical. So if you divide everything by t to the power 4, uh, so your denominator, okay, it's easy to write like this. So put in cubic root, 1/3 power is cubic root, right? Into the power 4 plus 2, right? And then we have right. So basically what we are doing is dividing and multiplying to the power 4/3, right? So when you divide that and then you 4/3. So 1/3 goes to infinity. Uh, so you divide this by this number. So you can actually take this part to the numerator, and then you can move that into the cubic root. And then 1/3 is going to taken by the cubic root, just like this, right? So now we can do, this is 1 minus, this is 1/3, this is 4/3. You have uh, two, 3/3, that means 1, right? So you have 9 divided by t here. And then this is cubic root of 8 plus this is 2t4. And we can use the power law, uh, and then this is 1 minus 0 divided by cubic root of 8 plus 0. So cubic root of 8 is 2. This is half. Uh, the answer is half. Okay. And let's do 43. Okay. Example 43. Limit x goes to infinity. Natural log 3x plus 1 minus natural log 2x plus 1. We have learned before in pre-calculus and log laws. We're going to use log laws here. Limit x goes to infinity. When you have a log um, uh, subtraction, you can write it as a log of division, like this. And we can actually take the limit of a log as a log of a limit. So we can do, it's a law that we learned previously. So we can move this into this log limit goes to infinity. Put that like that. So now I can divide this by x. that. And then it's natural log. This term goes to zero, this term goes to zero, this is 2, 3, and this is 2. So you have uh, natural log of 3 over 2. Okay, natural log of 3 over 2. Okay, because it's a composite function, right? Composite function. We can do like that, and we have learned that in previous sections. Okay, that's what I have for this lecture.